Welcome to Python for Scientific Computing 1. In today's video, I'm going to talk about for loops. For loops are extremely important for study of numerical techniques. This is because for loops arise in a wide range of applications, such as solving linear and nonlinear algebraic equations, solving ordinary and partial differential equations, performing linear and nonlinear regressions, solving multidimensional models such as artificial neural networks and deep learning. In addition, for loops also play a major role in analysis of imagery and remote sensing. For this reason, it's important for you to have a sound grasp of what for loops are and what do they do. Before we get into the syntax of for loop, let's understand the logic behind it. For loop is generally used when you have a sequence and you want to loop over every element of that sequence. For most part, I'm going to be using list as my data sequence, but you can apply for loops for, tuples, sets, as well as dictionaries. For loop does is it essentially goes in, picks the element, the first element, and then it checks if all elements in the list have been completed. So clearly, for the first element, it goes in and says that, well, I have not performed any calculations on this first element. So it goes down. This condition comes out to be no because that's not I have not looped over the last element, and then it performs a set of statements. And then once these statements are complete, it loops back and checks to see if all the elements in the in that data sequence have been subjected to these statements that are part of the code block of the for loop. If that's not the case, it'll pick the second element and then perform or subject it to a set of statements, go back, pick the third element, so on and so forth. Once it has performed the necessary calculations on the last element, then when it comes back to check, it says that last item looped, the answer comes out to be yes. So the for loop is exited and the data sequence proceeds downwards to the statement that's right below the for loop. So as an example, I have a list here, X, which comprises of a set of numbers, 1, 2, 4, 8, 10, 12, 20. What I want to do is I want to create another list Y where I take each element of X, multiply that by 2, and then take the square root. Remember, these two multiplication signs right next to each other indicates power in or raised to the power in Python. And if I raise a number to its power of 0.5, I'm essentially taking the square root. So what I really want to do is I want to take 1, plug it into this equation. So I get 2 times 1 is 2 plus square root of 1 is 1. So I get a value of 3. I want to store this in Y. Move to 2, multiply 2 times 2 plus take square root of 2, add that and store it in Y, and continue doing it for every element that's in that list. All right. To do that, I can make use of a for loop. So I have my X. This is the list I'll be looping over. Y is an empty list, and you can create an empty list by simply putting open and close square brackets with nothing in between. So this creates an empty list. Okay, so I have an empty list. And then I write my syntax for the for statement. I say for E in X. X again is this list that I want to loop over. And this E is a temporary variable in which I'm going to pick one element at a time from X and put that into E or assign it to E. Okay. So for example, in the first iteration, E will have a value of 1. In the second iteration, E will have a value of 2. Third iteration, E will have a value of 4, so on and so forth. And then this colon here indicates that I am putting a code block. This code block will work as long as I can grab an E from that list X. Okay. And then in the code blocks, notice that the code block is indented. And then I put z is equal to 2 times e plus e raised to the power of 0.5. I'm also going to round this to 2 decimal places. Whatever I have calculated here shows up here on the right-hand side. And I'm going to round it up to 2 decimal places and essentially overwrite it back into that z. So this way, I'm not creating new variables and using up more memory. I'm just using this z calculation and then using that z temporarily to round it and store the value into z. And once I have that z, what I want to do is I want to go to this list y and append the value that I just calculated. All right. So initially, e will assume a value of 1 because e is in x, comes in here, multiplies 1 with 2, takes the square root, rounds it to 2 decimals if necessary, and then appends it to z. Then it goes, picks up 2, it multiplies 2 times 2 plus square root of 2, which comes out to be 4 plus 1.414, and then it rounds it to 2 decimals, so it becomes 4 plus 1.41, which is 5.41, and then appends that value. Then it picks 4. 4 times 2 is 8, plus square root of 4 is 2, so it gets a value of 10, rounds it to 2 decimals, and appends it, and continues doing till it reaches this 20. When e picks up 20, it goes in, makes that calculation, 20 times 2 plus square root of 20, and then rounds it to 2 decimals and appends it. And then when it goes back, it sees that, well, I have no more elements to pick from x. I have worked on every element that's out there, so it simply exits the loop and then goes to the next statement, which is in line with this for. So it is not part of the code block, and it'll print this value and it'll say the values of y comma y, and then continues to move downwards. So when I run this, you will see the values of y because it loops through, gets the values, and then stores them in this y, and then eventually it'll print the y for me, which has all these values. So that's how Python traditionally does for loops. For loops are done on an element by element basis and on a single list. Even though Python by default only allows running a for loop on a list, you can use indices as well. For example, I have X, which is this list up here, 1, 4, 8, 9, 10, 2.3, 5.2, 6.1. And then I have another list Y, 2, 9, 8.7, 4, 1, so on and so forth. What I want to do is I want to take an element of X and the corresponding element of Y, multiply those two, and then store them in a new list called XY. So I have my X, I have my Y, both of these are inputs. And then my XY is where I'm going to be storing my outputs. And for that, I have initialized an empty list. What I've also done is I have initialized an index of I equals 0, and I will explain to you shortly as to what this index does. Now, since both these lists are of equal length, I'm gonna loop over X, and I'm gonna say for E in X, okay? And when I do for E in X, E gets a value of 1. And then I also need to pick the value of Y. To pick the value of Y, I'm going to put Y of I. The square bracket here next to Y indicates that I want to pick the value based on an index. My index was 0 initially, so it'll put this value of 0. Y of 0 is 2, which is the element in the first index. So it takes 2 times 1, multiplies it, and appends it to EY. Then it goes down, and before it goes back to the next iteration, it performs another calculation. In this calculation, what I'm doing is I'm saying I plus equal to 1. This is simply a fancy way of saying I want I to be equal to I plus 1. So whatever my old value of I was, which was 0, I'm going to add 1 to it or increment it by 1. And then, so the new I becomes 1. And when it goes back, it picks E is 4. So I got my value of E, and now it's going to pick Y of 1, the value of Y at index 1. This is index 0, this is 1, so it'll pick 9 times 4 will give me 36, and then it'll append that value. And then it'll go down, increment my I by 1, so from 1 it goes to 2, and then it picks the third element of E of X into E, which is 8, and then it picks the third element of Y, because Y of I equals 2 is the third element, which is equal to 8.7, and then it multiplies those two, and then appends it, increments, and continues going. And when E reaches this final one here, E of Y of I will be equal to 12. It will multiply those two, append it, increment this I by 1 and go back. But of course, there is nothing more to pull from X. So the loop terminates and then comes out. And then it prints X, Y to be what these values are. So that's how you loop using an index. Here I'm looping over one variable X traditionally by directly accessing the element value from the list one at a time, whereas I'm accessing the elements of another list using the index of that list. And of course, if you can directly run over an index, both the lists. So to do that, I have A and B, and these are two lists. Again, these two lists are of equal length. And what I'm going to do here is I'm going to calculate the length of the list. The length of the list is the number of elements in a list. So it goes to be 1, 2, 3, 4, 5, 6, 7, 8. So the length of the list will be equal to 8. Again, length of B is 1, 2, 3, 4, 5, 6, 7, 8. So N is 8. Now I'm going to create a new object called IDX. And IDX is going to have a data structure of range. And this range values start at 0. So 0 is inclusive. And then they end right before n. Okay, so they go up to n, but they don't quite go to n. So n I know is 8, so it'll go from 0 to 7 because I'm going in increments of 1. So this IDX is basically an iterator or a range variable that has values of 0, 1, 2, 3, 4, 5, 6, 7. Now I create an empty list again where I want to store my output. And then I'm going to loop now for I in IDX. So I'm looping not over A or B, but I'm actually looping over this index IDX. So IDX, first it'll pick 0. It'll take A of 0 plus B of 0 divided by B of 0 plus 2. A of 0 is 1. B of 0 is 3, so the numerator is 3 plus 1, which is 4, and the denominator is 3 plus 2, which is 5, so I have 4 divided by 5, which is 0.8. It goes down, rounds it to the 2 decimal places if necessary, and then appends it to this C. So C dot append, the value of Z is getting appended to C. Then it goes back, it picks the next value in that index. The next value in that index is 1. Again, A of 1 will be 2, B of 1 will be 4. So 4 plus 2 is 6, divided by 4 plus 2 is 6. So 6 divided by 6 is 1. It'll round it if necessary, and then append it and continue to the next element of IDX, which happens to be 2. Again, uses that as an index and pulls the values as necessary. So you can see that you can use a range object that starts at 0 and ends at n or ends right before n and loop over multiple lists of equal. If you want to use this approach, you can certainly, and you have two lengths that are of unequal lengths, you can loop over the shorter length without any problem, but some elements of the longer list will never be computed. But you cannot loop over a longer list because Python will throw an error once it is unable to access the elements from the shorter list. There are two other important statements that come in handy when you do for loops. One is the break statement, and the other is the continue statement. The break statement allows you to break out of the loop if a certain condition is met. So typically, if you want to include a break statement, you will include an if statement or an if else statement to check that condition. So here I have A, which is a list again, and I'm going to go for I in A. I is a temporary variable. It keeps on pulling values one at a time. And then the C is basically I plus 10. So the first time it will go to I, will pull the value of 1. 1 plus 10 is 11. It goes in and checks, is C greater than 30? Clearly it's not. So if is not valid, else is valid. So it appends that value. Similarly, it picks 4. 4 plus 10 is 14. Again, checks this if statement. Since 14 is not greater than 30, if is not valid, goes and appends it. Similarly, when it pulls out 19, 19 plus 10 is 29. Again, if is not valid, it goes to else. 22, once it goes to 20, 20 plus 10 is 30. Again, if is not valid because C is not greater than 30, it's just equal to 30. So again, it appends it. And then when it gets to 22, 22 plus 10 is 32. 32 clearly is greater than 30. So it'll break out of the loop and go to the next statement, which is print B, and prints these 4 values. On the other hand, if I have a continuous statement instead of the break statement, what happens is it works the same way for 1, 4, 19, 20. But when it hits 22, 22 plus 10 is 32. Clearly 32 is greater than 30. Rather than breaking at this point, it will just go back to the beginning of the for loop and pulls the next element. It pulls the next element 30. 30 plus 10 is 40. So clearly 40 is greater than 30. So the continuous statement kicks in and goes back and then pulls 10. 10 plus 10 is 20. So clearly if is not valid for this 10. So it appends that 20. So if you notice, the break, once I hit 22, the break statement got enforced and I no longer was able to get values for 22, 30, and 10. Whereas here, I am able to get the value for the 10, which is 20, the new value, which is 20 after the calculation put in here. So break statements and continuous statements are important if you want to filter a long list or filter data to meet a certain criteria. You can also loop with dictionaries, tuples. Dictionaries are interesting because you have a dictionary is made up of a key value pair. So what you can do is you can loop over the keys. Okay. So keys are almost like indices, as you know, like, A is the key for the value 90, B is the key for value 80, C is the key for value 70, and D is the value for 60. So what I'm doing is I'm going to loop, it's going to go to A, and then the D of key is the value. I can access the value using the key, add some number to it, and append it to a new list and keep track of the list. Similarly, what I can do is I can access both the key and the value terms using this d.items. D again is my dictionary. So I want the items of the dictionary. I'm looping over the items of the dictionary. A dictionary, each element of the dictionary has 2 items. One is the key, one is the value. I'm going to store the key in the key, value in the value. And now I have direct access to the value that I can use to make calculations, append it. I can also write a new dictionary. So I can create an empty dictionary and use this new dict key is equal to V, and it'll create me a key value pair for this new with the new values that it just calculated inside that code block. So in summary, a for loop iterates over a sequence of elements. I've shown it mostly with lists, but you can iterate over tuples and sets. You can also iterate over dictionaries using key value pairs or items. For loops, traditionally in Python, uses one list and iterates over each element of that list. And of course, you can always create a range object for index or manually initialize an index and then loop using that index as well. So these are some ways in which you can use for loops with one-dimensional data structures such as lists. Of course, we also saw how to use break and continue statements. In the next video, which is the second part of this lecture on for loops, I'm going to be showing some advanced techniques with for loop. Till then, take care and stay safe.